Turbulence, in aviation terms, refers to the irregular and often unpredictable movement of air that can affect an aircraft's stability during flight. This phenomenon arises from various factors, including atmospheric conditions, geographical features, and other aircraft-generated disturbances. Picture a flowing river. Just as it encounters rocks or obstacles, the smoothness of its surface is disrupted, creating ripples and eddies. Similarly, when an aircraft moves through the atmosphere, it interacts with pockets of air of different temperatures, wind speeds, or pressures. This interaction causes fluctuations in the air around the plane, leading to turbulence. Turbulence isn't usually hazardous but can vary in intensity. Pilots receive weather reports and use onboard systems to anticipate and navigate through turbulent areas safely. Modern aircraft are built to withstand significant turbulence, ensuring passenger safety remains a priority. Turbulence is a natural occurrence during flights, caused by complex interactions in the atmosphere. Pilots are trained to handle various levels of turbulence, ensuring a safe and comfortable journey for passengers. Below 15,000 feet, low altitude, turbulence in this range can stem from factors like surface heating, convective currents, and terrain disruptions. It's commonly experienced during takeoff and landing phases, especially near mountains, coastlines, or areas with atmospheric instability. 15,000 to 30,000 feet mid-altitude, this range might encounter turbulence due to weather patterns, jet streams, and frontal systems. Clear air turbulence (CAT) is more frequent in this zone, often associated with high-altitude winds. Above 30,000 feet, high altitude, pilots and passengers might experience turbulence caused by strong jet streams and atmospheric instability. This zone is where CAT is most prevalent, sometimes occurring without visible signs or predictable weather patterns. Turbulence in aviation can be categorized into various types based on its causes and characteristics. Here are the main types. Convective turbulence. This type results from convective currents caused by uneven heating of the Earth's surface. It's commonly experienced in warm, unstable atmospheric conditions, often near cumulus clouds or in areas of significant temperature differences. Convective turbulence can lead to bumpy rides, especially during hot afternoons. Clear air turbulence (CAT). CAT occurs in cloudless or clear skies, typically at higher altitudes above 15,000 feet. It's often associated with strong jet streams, wind shears, or atmospheric pressure changes. This type of turbulence can be sudden, unexpected, and challenging to detect visually or through conventional weather observations. Mechanical turbulence, generated by the interaction of airflow with various obstacles, such as mountains, buildings, or even other aircraft. This type of turbulence is more common at lower altitudes and can affect flight stability, particularly during takeoff and landing or while flying close to terrain features. Wake turbulence, produced by an aircraft's wingtips as it moves through the air. Larger aircraft generate more significant wake turbulence that can affect smaller aircraft following behind, especially during takeoff and landing. Pilots maintain separation distances to avoid encountering potentially hazardous wake turbulence. Mountain wave turbulence, generated by strong winds interacting with mountains, creating oscillating air currents on the leeward side of the mountain ranges. This turbulence can extend for hundreds of miles downwind and can be hazardous to aircraft flying in these areas. Thermal turbulence arises from rising and falling air currents due to temperature variations. It's commonly experienced during sunny days, especially over large land masses, and can cause the aircraft to experience sudden lifts or drops. Understanding these various types of turbulence helps pilots anticipate and navigate through potentially turbulent areas, ensuring a safer and more comfortable flight for passengers and crew. Turbulence intensity refers to the degree or level of disturbance experienced by an aircraft during flight. It can vary from light, which might cause slight discomfort, to severe turbulence, which can pose potential risks to both passengers and the aircraft. The types of turbulence intensity are generally classified as follows. Light turbulence, characterized by slight erratic movements of the aircraft. Occupants might feel a slight strain against seat belts, and loose objects may be displaced. It rarely causes any concern for the safety of the aircraft. Moderate turbulence, more intense than light turbulence. Moderate turbulence results in variations in altitude or attitude. Occupants may be forced momentarily out of their seats and unsecured objects can be tossed around. The aircraft aircraft remains in control, but pilots may maneuver to minimize discomfort. Severe turbulence. This level of turbulence is significantly disruptive, causing large and abrupt changes in altitude or attitude. Occupants might be lifted out of their seats, and there's a risk of serious injury if not securely belted. Structural damage to the aircraft is unlikely, but safety measures are crucial. Extreme turbulence. Extremely rare and highly dangerous, extreme turbulence causes violent and unpredictable aircraft movements. It can exceed the design limits of the aircraft and cause structural damage. Extreme turbulence poses severe risks to both passengers and the aircraft's integrity. Pilots use various means to assess and report turbulence intensity, such as visual observations, reports from other aircraft, weather radar, and automated sensors on board. They also communicate turbulence intensity to air traffic control and provide advisories to other aircraft to help them anticipate and navigate through turbulent areas for safer flights. Turbulence, in most cases, does not cause modern commercial aircraft to crash. Commercial aircraft are designed and built to withstand a considerable amount of turbulence. Pilots receive extensive training on how to manage and navigate through turbulent conditions safely. However, while turbulence itself is generally not a direct cause of crashes for modern commercial aircraft, severe turbulence can pose risks and lead to incidents or situations that may potentially endanger the safety of the aircraft or passengers. For instance, injuries to passengers and crew. Severe turbulence can cause passengers and crew who are not properly secured in their seats to be thrown about the cabin, leading to injuries. This is why passengers are advised to keep their seatbelts fastened even when the seatbelt sign is off. Structural stress. Intense turbulence can subject an aircraft to considerable stress. While commercial airplanes are designed to withstand such forces, extreme or unexpected turbulence could potentially lead to structural damage. Loss of control in rare cases. In extremely rare instances, if an aircraft encounters extremely severe turbulence or a combination of adverse factors, it might lead to a temporary loss of control. However, modern flight control systems and pilot training are designed to handle such situations to regain control and ensure the safety of the aircraft. It's important to note that pilots receive weather reports and use onboard weather radar to anticipate and avoid areas of significant turbulence. They can adjust altitude or change course to navigate around turbulent areas, ensuring a smoother and safer flight for passengers. Overall, while turbulence can be uncomfortable and occasionally alarming for passengers, modern commercial aircraft are equipped to handle most turbulence encountered during flight without compromising safety. Pilots are trained to prioritize passenger safety and to navigate through turbulence to ensure a secure and controlled flight experience.